Friends, here's the ultimate calculus challenge. We are integrating rational functions that only differ slightly on top and bottom, yet they call for whole different integration methods. Go ahead with number 1, please.
Okay, so for this first one, you would just need to simplify. So you have x over x, which would be 1, and then 1 over x, and then that's just basic integration. You have x plus ln of x
Sweet.
plus c. For this question, you define x plus 1 as u, and then you get du equals dx, and you define x as u minus 1, and then you just plug these new values back into the question, and then it's similar to this one where you just simplify and some basic integration, plug back in u. As for this next question, you have U substitution again, so u equals x plus 1, which would be 1 over u, which is ln of u, and then you just plug back in u.
Okay. This here is a trig integral. It is the same as inverse tangent of x plus c. So that's your answer right there. This is simple U substitution. You plug u as x squared plus 1, and then you simplify, integrate, you get, a half ln of x squared plus 1 plus c. 6, this can be this can be split up, and this requires partial fractions. You do the long method or the cover-up method to get a equals a half and b equals a negative half. Then you simplify that all the way down to this, and you integrate, which will get you ln of the square root of x plus 1 over x minus 1 plus c.
Number 7's got 2 really easy solutions to it. The first one is fraction simplification, factor out of 2, perfect squares definition, drop out the x plus 2's, and differentiate with an ln rule right here.
Maybe integrate.
Integrate, pardon me. This one is U substitution, define the whole bottom as u, and the derivative of u is the exact same as the numerator, so you can plug that in for u, and then same thing, ln integration, plug back in u, and use some ln rules to get you back to your answer. Number 8, perfect squares definition. Since u right here, du is 1, you can skip a step and just make this u squared. Then 1 over u squared, so then use power rule. U to the negative 2 turns into negative 1 over u, which is negative 1 over x plus 2, based on what we defined u as. This one right here, you manipulate this fraction to add a 1, so you get a perfect square plus 1, which is also a perfect square. Since x plus 2, if we define that as u, du would be 1. We don't need to do anything to manipulate the integral. So then it becomes the definition of tangent inverse integral. And you plug back in for u, and you get your answer. Don't forget C.
Or J. What about 10?
10?
10.
10 is partial fractions. Okay.
How do we know that?
10
It looks like 9.
For 10, you factor out the very bottom of this, and the difference between 10 and 9 is just one number off of your one number makes all the difference. Split this up, split the integrals into 2 additions. You can prove that these are negative 1/3 and 1/3 through cover-up method or the long method where you use a and b or a and a1, whichever one you pick. Then use ln differentiation to get to the very bottom.
And differentiation is still integration for you?
Yep.
Okay, good.